All right, so the last class of lipids that we'll discuss in this class are the eicosanoids. And eicosanoids are all made from arachidonic acid, which is a 20 carbon fatty acid with 4 double bonds. And so it's a polyunsaturated fatty acid. The arachidonic acid is converted to 3 different types of eicosanoid. Oh, and they're called eicosanoids because of that 20 carbon. The eikos means 20. So anyway, the eicosanoids are the arachidonic acid is converted to prostaglandins, which cause pain and inflammation. So they're an important signaling molecule in the body, because if you can't feel pain, then you don't realize when something might be dangerous. If you accidentally touch a hot stove, you'll only pull away from the hot stove because you feel the pain from the heat. If you couldn't feel the pain, then you'd leave your hand on the hot stove and get a really bad burn. But another class of eicosanoids are the thromboxanes, which are involved in blood clotting. And so that's another important function. And leukotrienes, which are involved in a lung muscle contraction. And so these are related to asthma. That some asthma medications are designed to inhibit leukotriene function so that the muscles around the lung don't contract, and it makes it easier to breathe. But anyway, we'll try drawing out some structures of these. Hopefully, I can make them large enough on this board to be visible. That arachidonic acid is sort of a U-shaped lipid. Or at least it's often drawn U-shaped because it would be too long to draw in a straight line. And so this, again, is arachidonic acid. And it's the starting material from which all the other eicosanoids are produced. And so we'll start with the prostaglandins. You have this 5-membered ring with a ketone and an alcohol group. And then this one lipid arm with a carboxylic acid. And another lipid arm with a hydroxyl group. And so these, this particular one is prostaglandin E2, and it's actually involved in signaling pregnant women into induced labor. So that the end of the pregnancy, prostaglandin E2 is used by the body to tell the body to have the baby. Another molecule is, we'll do a thromboxane. So we have a six-membered ring, six-member cyclic ether. We have this oxygen, and it's actually a bicyclic ether because we have a second oxygen atom that joins these two carbon atoms together, and so it's a fairly complex structure. And again, we have two lipid arms. One with the carboxylic acid, and the other with a hydroxyl group, and this would be thromboxane A2. And finally, we'll draw a leukotriene. And this leukotriene has a group we haven't mentioned before, and that's a three-membered ring with an oxygen, and that's called an epoxide group. And go ahead and label this as leukotriene A4. So there are many different prostaglandins, many different thromboxanes, many different leukotrienes. And so they're given these E2, A2, A4 identifiers in order to tell specific molecules apart. A little more about the epoxide. It's unrelated to the rest of this. It is that this epoxide ring is highly reactive, and other molecules can attack either one of these carbon atoms and open up that ring. And if you've ever used like an epoxy resin as a glue, you'll have like these two different substances that you mix together in order to make the resin turn solid. That it uses these epoxide groups. So one substance will contain the epoxides, and the other substance will contain the stuff that reacts with the epoxides. So you mix them together to form a polymer. But anyway, that's not really related to the eicosanoids. But another interesting story about the eicosanoids is probably a little before your time. That in the late 1990s, a series of really effective painkillers were produced called COX-2 inhibitors. COX-2, and that COX stands for cyclooxygenase, and cyclooxygenase is one of the enzymes responsible for producing the prostaglandins and the thromboxanes from arachidonic acid. The reason like aspirin and ibuprofen work is by inhibiting both COX-2 and COX-1. Now, the COX-1 inhibition causes side effects like stomach damage and kidney damage, and so you can overdose on aspirin and ibuprofen, and that'll cause severe stomach problems. Whereas COX-2 inhibition is good for painkillers. And so in the late 90s, there were a series of COX-2 inhibitor painkillers produced that were very effective. But after a few years, people noticed that people who were taking these COX-2 inhibitors had more heart attacks than people who weren't. And so we discovered that the COX-2 inhibition led to heart damage and heart attacks. And so the COX-2 inhibitors were taken off the market. And so quite a few people complained because they were really effective painkillers. But for safety reasons, we don't use them anymore.